In the previous video, we talked about the first two steps of the conversion from ER model to relational model. Okay, and in this video, we are going to be talking about the third step of the 7-step procedure. Okay, or 7-step algorithm of converting ER model to relational model. Right. So the third step is about mapping of 1:1 relationship type, or I should say mapping of binary 1:1 relationship types. Okay. Why binary? Because we are talking about binary relationship types. What is binary relationship types? Binary relationship types are the one in which there are two participating entity. Okay. For example, this particular relationship type works for, right? So how many entity types are participating in it? Two entity types. One is employee and one is department. So this is a binary relationship type. Okay. So a binary relationship type is the one that has a degree of 2. Right? And what is the degree? The number of participating entity types, right? So the third step talks about mapping of binary 1:1 relationship types. That is, if we have a binary relationship type of 1:1 cardinality ratio, then how do we map it to relational model, right? So this is a relationship type of cardinality ratio n:1, right? So in this step, we are going to be talking about 1:1 relationship type. That is a relationship type like this. What is this relationship type? Manages. And this is a 1:1 relationship type as represented by this diagram or ER model diagram. Okay. So this relationship type manages the 1:1 relationship type between these two entities, employee and department, right? So how do we map binary 1:1 relationship type? Firstly, we need to identify the relations in relational model that correspond to the participating entity type, right? That is, let us say if we have this relationship type manages, right? So which entity types are participating in it? Employee and department. So the first step is identify the corresponding relations in the relational model, right? So how employee entity type was represented in relational model? By this relation employee, right? And this department relation, department entity type, the corresponding relation for this particular entity type is department relation, right? So these two relations are the ones which we will deal with, or which we have to use in order to convert this relationship type into relational model, right? So these are the two relations corresponding to these two participating entity types. Okay, so we can do this mapping by 3 approaches. Okay, there are 3 approaches in order to map 1:1 relationship type or binary 1:1 relationship type, right? So there are 3 approaches. The first one is the foreign key approach. Okay, where should I write? Okay, so I don't think there is a need for this as of now. Okay, so there are 3 approaches. So the first approach is foreign key approach. Okay, and the second approach is merged relation approach. Okay, and the third approach is cross reference or relationship relation approach. Cross reference or relationship relation approach. Okay, so when we deal with 1:1 binary relationship type, the most popular approach is the foreign key approach, right? So first we look at foreign key approach, right? What are these 3? These 3 are approaches by which we can map binary 1:1 relationship type into relational model, right? So in the foreign key approach, what we do is we include as foreign key in one of the relations the primary key of another relation, right? So which relations? The relations corresponding to the participating entity types, right? So which two relations are corresponding? Employee and department, right? So we will include in one of the relations of these the primary key of another relation. That is, either include as foreign key in employee relation the primary key of department relation, or include as foreign key in department relation the primary key of employee relation, right? So either I can include department number here, let us say I rename it as D number. Okay, so this is a foreign key in employee relation that refers to this particular relation, right? And what we have included? We have included the primary key of this relation, right? Or I can include the primary key of employee relation as the foreign key in the dependent relation. What is the primary key of department relation? Employee. Sorry. What is the primary key of employee relation? SSN. So I can include SSN here. Okay. Or I can even rename it and include it, right? So this is a foreign key that refers to this particular attribute of employee relation. Okay. Either ways can be done, right? So what does it represent? If in case if we think about it, in case if we include in the department relation the foreign key, it means for every department tuple we are recording the we are recording the social security number of the manager of this department, right? Why? Because we are depicting the relationship type manage, right? Manages is the relationship type, which means that this particular department is managed by this particular employee, that is, or if this particular department is managed by an employee whose social security number is this and this, right? Or if we include it on the employee side, the primary key of this D number, then for every employee it will include the department number that the employee is managing, right? So these are the two ways. But what we do generally is we include foreign key on the side that has total participation in the relationship type, right? So which entity type has the total participation in relationship type? Department entity type. Okay, why? Because this is double line. So double line means that this has total participation in the manager's relationship type. In case this has the total participation, then what happens is, in case this has total participation, then it means that for every department there is a manager, but not every employee is manages some department, right? This is logical, right? So for every department there is a manager, but not every employee manages a department, right? So we include foreign key on the side that has total participation, that is we include foreign key on the side that has total participation, that is department number, right? That is in the department relation we are including the foreign key, right? So why is it happening? Let us say I am not including SSN and I rename it as MGR SSN. Okay, so now it represents the SSN better, that is it represents the SSN of the manager, right? So why we are doing this and not this? Because since not every employee is a manager, what happens in case I include D number here, in case I include D number of the department that if this particular employee is managing here, what happens? Let us say there are 100 employees and only 10 of them are managers and 90 others are not managers, right? So for every employee tuple, for 90 employee tuples, the value of D number will be null. Why? Because these employees are not managing any department, so D number will be null for these 90 employees. Only for 10 employees that D number will have some value, right? That represents the department number that a particular employee is managing, right? So for 90 tuples we have to include null values, right? So in order to avoid it, what we do, we include it on the department relation. In case there are only 10 departments, then for every department we are including MGRSSN, that is social security number of the employee that manages this particular department, right? So in that case we can avoid null values. Okay, so that is the reason why we are including foreign key on the side that has total participation. Okay, it is not necessary, but it is how it should be followed. Like, it is a better way to do it. Okay, so include foreign key on the side that has total participation in the relationship type, right? And also in case this has any simple attribute, the relationship type has any simple attribute. So this manager's relationship type has an attribute start date, that is the date on which employee started managing a particular department, right? So this is a simple attribute, so include that too on the side on which you have included the foreign key. So we have included foreign key here, so we will include this attribute also here. Let us rename it as MGR start date, that is the date on which the manager started managing this particular department, right? So that is how we converted this 1:1 relationship type into a relational model by this foreign key approach, right? What we did, we included the foreign key of one relation as the primary key of another relation, right? And we can do it either ways. In case of 1:1 relationship type, in any of the relations we can include the foreign key, but we do it on the side, but it is better to do it on the side that has total participation in the relationship type in order to avoid null values, right? So now let us talk about the second approach, that is merged relation approach. How can we map binary 1:1 relationship type into relational model using this particular approach called as merged relation approach. Okay. So in merged relation approach, what happens is both the entity types and relationship type are represented in just a single relation. Okay. So this approach is not very popular when it comes to the mapping. Okay, but it can be useful when there is total participation from both the sides. Then this approach can be popular. That is, we can represent both the entity types as well as the relationship type in the single relation, right? So that is about the merged relation approach. Okay, and this cross reference or relationship relation approach, this we will be going to look in detail when we are talking about mapping of binary MS to N relationship type. Okay, in that we will discuss about it, and also we will see how to map 1:1 relationship type as well by using this particular approach. Okay, so for now just remember that for mapping of binary 1:1 relationship type, we have to, the most popular approach is the foreign key approach, right? Now let us move on to mapping of okay, so these relations are called as, like employee relation is called as entity relation. Okay, so this is called as entity relation because they are created by mapping of entities into relational model, right? So these are called as entity relation. Also every tuple in this particular relation represents an entity instance, so these are called as entity relations. Okay, now let us move on to mapping of binary 1:N relationship types. Okay, binary 1:N relationship types. Okay, this is the step number 4. Okay, so this is the relation. As a result, these are the two relations as a result of these 3 steps that we did. Okay, 3 steps of mapping. So mapping of binary 1:N relationship type. So which relationship type is N:1? This. Employee works for a department, right? So this is an N:1 relationship type. So what we need to do for N:1 relationship type, for every N:1 relationship type, again we have to first identify the relation that corresponds to the entity type at the N side. Okay, so here we have to identify the relation that corresponds to the participating entity type at the N side, which means whichever entity type is on the N side, that is, which one is the only N side? Here it is N side, this is one side, right? Is it visible? This is one side. Okay, so this is N side, this is one side. So whichever entity type is on the N side, like this here, employee relation is on the N side, identify the corresponding relation in the relational model, right? So which is the corresponding relation? Employee relation, right? So on this side, we will include the foreign key in case of N:1 relationship type, right? In case of 1:1 relationship type, we had the flexibility. We could include foreign key on any of the other side. Even it was better to include it on the side that has total participation. We had the liberty to include it on any side. But in case of N:1 relationship type, we have to include the foreign key on the relation that corresponds to the N side of the relationship type. Okay, so we have to include foreign key on the employee relation, right? So we include foreign key. So which is the foreign key? Include as foreign key the primary key of the relation corresponding to the other participating entity type, that is C. These are the two participating entity types. So what we do, we always include as foreign key the primary key of other relation, right? So we include as foreign key in the employee relation. Why? Because it is on the N side of the relationship type, right? On include as foreign key here, what we include? The primary key of this relation, okay? The corresponding relation to this particular participating entity type. So department entity types corresponding relation is department. So include the primary key of this D number, department number here. So what it represents? It represents the department number for which is employee is working for, right? This is a works for relationship. So it represents the department number for which employee is working, right? So include as foreign key in the N side the primary key of the other participating entity type, right? That is this one. Again, we created this in the previous also, right? But there it was for managed while giving example, and here it is for works for, right? So what we did for N:1 relationship type, simple. First identify the N side. Okay, so N side is employee. So on the employee we have to include foreign key. So what will you include as foreign key? The primary key of other relation or the other participating entity type. What is the other participating entity type? Department. So its primary key is number. So you include number as foreign key here. So we have just renamed it as D number. Right? So why we are doing this? Why we are including on N side and why not on one side? Okay. So it is because every entity here is related to at most one entity there. Okay. You can also infer this relationship type as employee works for at most one department. Department has at most n employees. Okay. Department has at most n employees. An employee works for at most one department. Right. So in case I include on department side, right, in case I include on the department side the primary key of here, that is the primary key of this side, that is for every department if I include the SSN of the employees that it is having. Okay, so in that case it will become a multi-valued attribute. Why? Because a department has n employees at most working for it, right? So a company has many employees, a department has many employees working for it. So in case I decide to record social security number of employee on department side, what will happen? Every department has many employees, so we will have to include a multi-valued attribute here. For every department we have to record all the social security number of all the employees that are working for a particular department. So it will become a multi-valued attribute. But in case we are including on the employee side, since every employee is working for at most one department, there will be at most one value here, that is it will be a simple attribute, right? So in order for this to not to avoid dealing with multi-valued attributes, what we have done is we have included foreign key on the n side, right? So that is how mapping of binary 1:n relationship type is done, again using foreign key approach, right? So the most common approach for 1:n or 1:1 relationship type is foreign key approach, right? So that is how we did it. Again, if there are any simple attributes also, include that too on the side on which you have included the foreign key. So there are no simple attributes for the works for relationship type. In case there were, we would include on the side on which we have included foreign key. So which side? Employee side. So employee, here only we would include the attribute that was present on the relationship type, right? So that is about mapping of binary 1:n relationship type, right? So now let us move on to mapping of m:(n) relationship type. Okay, mapping of binary m:(n) relationship type. Okay, so let me erase it, and here only I'll create. So this is the relationship type m project. Okay, name, number, location, works on. Okay, so this is the m:(n) relationship type that we are trying to map into relational model, right? So this is another entity type, project, which has attributes name, number and location. Okay, in case I had included it earlier only, we would have dealt with it in first step, that is mapping of regular entity type. Since this is a regular entity type, we would have mapped it there. How? We would have just created a new relation. This is not required as of now, right? So we would have just created another relation, project, in the first step only, project that has name, let us say p name, let us say we have renamed it p name, p number and p location. Okay, and since it has two key attributes, we can take any one of it and make it as primary key. Let us say we make project number as primary key, right? So now let us talk about mapping of binary m:(n) relationship type. Okay, so for binary m:(n) relationship type, what we do is, for every m:(n) relationship type, we create a new relation. Okay, so this is new. For m:(n) relationship type, we have to create a new relation. Okay, and the name of this new relation will be, the name of the relationship type, right? That is works on. Okay, so we create a new relation, and now what we do is we have created a new relation. Now in this new relation, as attributes, what we include? The primary key of the participating entity types, or the primary key of the relations corresponding to the participating entity types, right? So which are the participating entity types? Employee and project. And what are the corresponding relations? Employee and project. So include its primary key of both the relations as foreign key here. Okay, so include ESSN. Let us say I have renamed this, and I have also renamed this as P number. Okay, so these two are referencing here. Okay, because these are foreign keys, so these foreign keys are referencing to these two relations, employees and project relations, right? So these two are referencing here. Okay, so that is how we created a new relation. That is, for every, we are including since every employee can work on many projects and a project can have many employees, so it is not possible to include it as a single foreign key or use foreign key approach for this, right? So what we do is we create a new relation, right? And on new relation we have included the primary key. That is, we can just include that employee 1 is working on project 101, employee 1 is working on project 102, and project 102 is again worked upon by employee number 3, or something like this, right? So this is how the relationship works on, is represented in relational model, right? So also, in case so the primary key for this particular relation will be the combination of these two. Okay, so the primary key will be ESSN comma P number, the composite attribute. Okay, so why? Because every employee can work on many projects, and a project can be worked upon by many employees. So none of these two, if we consider, if we only try to make ESSN as the primary key, it would fail, because there are many employees that are working on because an employee is working on many projects. Similarly, in case you want to make P number as the key, it will fail because the project is worked upon by many employees, right? So the combination of this will be unique, right? So 1 and 101, right? Sorry, 1 and 101, it's not 1 and 101. The combination will become the primary key for this new relation, that is the relationship relation. So this approach is called, that the third approach that we discussed here, cross-reference or relationship relation approach. This is called a relationship relation because we have converted the relationship type into relation, and here every tuple in this particular relation represents a relationship. Okay, so every instance or every tuple in this particular relation represents a relationship instance. So this is why it is called as a relationship relation, right? So which relation it is? Works on relation, right? So now let us talk about how to represent n:1 and 1:1 relationship types. Also, how can we convert, or how can we represent n:1 relationship type and 1:1 relationship type using this approach or cross-reference approach, right? So in case we want to represent 1:1 relationship type using this approach also, okay, so we have in case there are any simple attributes on this particular relationship type, okay, so I just forgot to add it. So in case there are any attributes, any simple attributes attached to this particular relationship type works on, then include that too on this relationship relation. That is, let us say here hours is an attribute. Okay, so hours is an attribute that records the number of hours the employee is working on a particular project, right? So this is an attribute that is attached to the relationship type, so include that too on this relationship relation. Okay, so include hours also as an attribute here, right? So with this we are done with mapping of m:n relationship type using cross-reference or a relationship relation approach, right? So it is not possible to represent it using a single to include as a single foreign key in any one of the relations. It is not possible for m:n relationship type, because every entity here is related to at most n entities here, and every entity here is related to at most m entities there. So it is not possible, right? So now let us talk about how to map n:1 relationship type also and 1:1 relationship type also using this approach. Okay, so for this approach what we will do is, there's a lot going on here. Okay, so we don't need this, right, as of now. So when we are mapping this relationship type, what we will do, let us talk about first 1:1 relationship type. We will create a new relation. manages, and again we will include the primary key of both the relations corresponding to the participating entity types, right? So which are the participating entity types? Employee and department. So employee and department's primary key will be included here, SSN and number, or let us say MGR, manager, SSN, and number, department number. Okay, so we can include, now this will reference to here and this will reference here. I know this is very clumsy, but try to understand it. Okay, so this is referencing MGR, SSN referencing here, and D number is referencing here, right? So this is how relation is created, and in case there is any attribute, include it here only, start date. Okay, and also the primary key for this relation can be any of MGR, SSN and D number. Why? Because because this is a 1:1 relationship type, right? So in 1:1 relationship type, there will be just one instance of every MGR or MGR, SSN, and one instance of department number, right? Let us say one department 10 is managed by manager number 321. Let us say MGR, SSN 321. Then 321 MGR, SSN won't be managing any other department, because an employee can manage at most one department, right? And also department can be managed by at most one employee, right? So there will not be any other instance of D number as well here, right? So D number can be primary key and MGR, SSN can be primary key. Any one of them can be the primary key for this new relation, right? As long as there are no null values here. Why? Because if there is a null value, then there will be violation of entity integrity constraints, right? So any one of these can become the primary key of this relationship relation in case of 1:1 relationship type, right? Now let us talk about mapping of binary N:1 relationship type, right? So in case, the same thing, in case of binary mapping of this relationship type, we will include the super key of the relations corresponding to the participating entity type. So which are the relations participating in this? Employee and department. So employee and department's primary key will be included here. So let us say ESSN, okay, and number, department number, and works for, okay. So, and this will be the foreign key, right? So these will be included as foreign key here, that will reference the primary key, right? So ESSN will refer here, D number will refer here, right? And in case there is also any attribute, then that will be included here as well, okay. And now again another thing, the primary key for this relation, the primary key for this relationship relation in case of N:1 relationship type will be the primary key of the relation corresponding to the N side participating entity, right? Which is on the N side? Employee entity. So employee entity's relations primary key, that is ESSN, will become the primary key for this. Why? Because an employee works for at most one department, right? But a department can have many employees. So in case I write department number 10, it can appear more than once here, right? Because many employees, 101, 203, 421, many employees can work for a department, right? But many employees can work for a department, right? But an employee 101 will not work for more than one department. It will work for at most one department. It cannot be a situation like this, right? So the primary key will be the primary key for this relation will be the primary key of the relation corresponding to the N side of the relationship type, right? So these are the main points that you need to keep in mind in order to map a binary N:1 relationship type and 1:1 relationship type into relational model by cross reference or relationship relation approach, right? So in this video we talked about all the So we talked about all the 5 steps of this algorithm. First two we had already discussed. In this video we talked about mapping of 1:1 relationship type, M:2 relationship type, and N:1 relationship type, right? So the only 2 steps are left which we will cover in the upcoming videos. And that's it for this video. In case you like it, then please don't forget to press the like button, subscribe to my channel for more such videos, and press the notification bell so that you get notified every time I put up a new video. I'll see you in my next one.